Morning friends, welcome back to your favorite channel Code One Digest. Today in this video we will learn how to set up EC2 instance from scratch, and then we will be deploying our microservices with Postgres database in AWS EC2 instance. Yes friend, we will do everything from scratch, from setting up the EC2 VM instance and then deploying our microservices with Postgres database into that instance. So yes, it is going to be very exciting and a lot of learning over there. I'm sure many of you wants to learn how can you run your microservices into EC2 instance with a database. So I'm going to show you that how can you run a Springboot microservices with Postgres RDBMS in AWS EC2 instance. Yes, friends. Okay, so stay with me till end of this video. It is going to be very exciting and interesting, and I'll show you step by step how to do this. So friend, here is the agenda. We are going to create and set up AWS EC2 instance. Then we will connect to that EC2 instance using key value pair. Then we will create a S3 bucket. S3 bucket will create because we have to upload our microservices jar and some media files. So for that we need S3 bucket. And from S3 bucket, we will transfer those assets to our EC2 instance, right? So for that reason, we'll be creating S3 bucket. Then I'll show you Springboot microservice, what I have developed and how it is going to work with Postgres database. Then we'll compile and build a jar. We'll upload that jar to our S3 bucket. Then we will install and run our Postgres database into EC2 instance. And then we will run our microservices into EC2 instance with Postgres database and we'll test those APIs. So all these things we'll do in this video. So stay with me till end of this video. It is going to be very exciting and there are a lot of learning here, right? Okay friends, so before we proceed into this video, let me explain you with the architecture diagram what are we trying to achieve in this video. So the blue area what you see here is the AWS environment. It's a AWS, and then we have this pink color box is EC2 instance. It's a virtual machine that we have. In that virtual machine, we are going to run microservices, and in the same box, we are going to run Postgres database. So before that, we will create S3 bucket, an instance of S3 bucket, and we will upload our jar and media files to that S3 bucket. From S3 bucket, we'll transfer those files to our EC2 instance to a location where we want to run our microservices. And then in this EC2 instance, we'll download and install the Postgres database from internet, and then we'll connect, and then we'll start our microservices to connect to this database, and then we'll test our APIs end to end as a user from outside, right? So this is the architecture diagram. It is a pictorial representation what we are trying to achieve in this video. With me friends, clear? Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you.
Let's go ahead and fire it up.
Okay friends, so now what we'll do is let us open AWS console and try to set up our EC2 instance. So in Google search for AWS AWS console login. Yeah, so it will take you to AWS management console. You have to log in. If you don't have an account, you can create a free account. It is free to create. I have already created an account. That is why I am logged in with that account. Now here we are going to create an EC2 instance. So in a search box type EC2. You can see that EC2 service is listed here. Click on that EC2. You will be taken to a EC2 dashboard, right? Then on your left hand side, you have to create on instances. You see here on left hand side, this instances. As of now, I'm not running any instances, hence it is not listed here, right? So we have to launch an instance. Click on this right top corner yellow button, launch instances. Right now you will land on this page where you will be setting up your EC2 VM instance. You have to provide certain details here like name of your server and the detail and configuration and so on. So we'll do that. Okay, so let me provide details to create this EC2 instance. So I'm going to give code one digest EC2 instance demo, right? So this is the name I'm giving. Then I'm taking this Amazon Linux default operating system. This is the server I'm going to take, and instance type I am taking T2 micro. You can select other instances as well, but I think for this demo this T2 micro is more than enough. I don't want hi-fi configuration. One CPU and 1 gigabit of memory is more than enough. Now here we have to create a key value pair so that you can securely connect to this instance from your local terminal, from your local putty. So if you don't have, I don't have a key value pair, so we can create a new key value pair. This is easy to create. I can say code one digest key value. I will take it as a RSA and I will download it as a PPK file because I am going to use it in putty. Okay, let me create this. Yeah, so that PPK file is downloaded. We have to keep that PPK file safe and secure. Later, we will use this PPK file to log in into our EC2 instance. Once we launch the EC2 instance, then from putty using this PPK file, we'll be connecting to it. Okay, I'll show you that. Fine. So that key value pair is selected here. Now let's create a network settings for our EC2 instance. Click on edit to update network settings. Here we will creating a firewall rule that will important to run our application. So if you see here, we have a default virtual private network, and then I'm not using any subnet, let it be default, and it's saying auto assign public IP enabled. It is creating a security group for me with this name launch wizard 1 and so on. Now here you see there's a couple of security group rules are defined, which is allowing that SSH TCP on 22 port. This is used to connect the putty connection. Then source type anywhere. What we are going to do is now we are going to add a new security rule with our custom TCP. Okay, we'll say TCP from anywhere and we'll say 8080. Okay, so source type we have selected anywhere and then we said 8080. 8080. Once this is done, storage, let it be with the default configuration of 1 pack of 8 GB, right? With GP2 root volume, and in advanced detail, we don't have to change anything. Let it be default configuration as is, and just click on launch button on your right bottom corner. Yeah, it will take a couple of minutes to launch your instance. Yeah, it says the instance is launched successfully. Now, what we want to do is we want to connect to this instance. So click on this connect to your instance. It will open a new window and it will guide you how can we connect to this instance. We want to connect to that instance using SSH client. So we'll follow this instruction. Now I'll show you how can we connect to this instance from our local. Let's see that. Okay, friends. Now what we'll do is we'll connect this EC2 instance with our putty from our local. So let me open the SSH client, that is Putty I'm using, and then we'll follow the instruction given here. So this is the host name of that server, so that I have to use here in the session, okay, as a host name that I have given. Then go to connections in SSH, go to auth, and then here select that ppk file that we have downloaded while creating the secret key pairs. So I'll just load that. This is my ppk file. Open that and click on open, right? So here it will ask for a username. So if you see in this command, the user is EC2 user. So this username we have to use and give it here. Yeah, and say enter. Here you go. So you are now into that server. You have logged in into that server. ULS pwd. Yeah, and just change it to a root user. Sudo su hyphen root. Yeah, so now we will do a setup as a root, and we'll create cd slash, let me create, and a directory application mkdir apple. Okay, so that application directory cd appl, so everything will run here. We will keep everything here in this directory. So okay, now let me install the Postgres on our EC2 instance. For that we have to update certain repository. We have to install epel. Let me do that. Yes, say yes. Yeah, this is done. Next step is we have to run this whole command to add the repository from where we can download this Postgres. Yeah, so it is added. Then we'll create some cache. Installing Mac cache created. Then this is a command to install our Postgres 14. So now it will download 14 and install it. Downloading. Yes. So it says complete. Installed installation complete. Let us initialize the database. Is a command to initialize database first time, so that it will create all the required file inside a data directory. Initializing database, it says yes, that's okay, it is done. Then we can go, our conf file is at this location. We can enable it and create a link using systemctl command so that it will be accessible. Yeah, created system link. Then let us see the status of Postgres 14. It is running, or what is the status? So yeah, it is running. It is up and running if you see. And then we will change to Postgres user, sudo su hyphen postgres. Yes, and then we can do psql to go inside the SQL prompt. psql. Yes, so we are into Postgres. Let me create a duplicate session. EC2 user. Yes, sudo su hyphen root. Now let me go to a file where we have our configuration file. Let us see cd this. So we have Postgres, vi Postgres. So here in this file, we will be updating the IP address from where we are going to allow the connections. Okay, so now what we'll do is in this file, we will be configuring so that it can allow the connection from any server. Let me copy this, paste this is equals to star. Yeah, and let's save this. Yes, we have saved this. And now we'll restart our service. Stop. Yeah, it stopped. Now we'll start it. Yes, let's see. Yep, it started now. Sudo su-postgres SQL /l. It is listing what all users and databases we have. So this is a Postgres database /c connect Postgres. Yes, so we are now connected to Postgres. Right, so it is working. Now what we do is we will try to connect to this database on EC2 server from our local using database tool like PgAdmin or DB Viewer. I'm using DB Viewer, but you can choose to use PgAdmin as well. So before we proceed for the connection, we have to update and allow all the server to connect to database. So hence we have to go and update in pg_hba.conf file. Go to your data directory of Postgres. Inside data directory you will find vipg_hba.conf. Open that and search for here. So at this line you will see it is allowing only localhost connection. Now what we do is we will add a line to allow all the connection from everyone, and for that we have to add this line all 0 0. That means we are allowing the connection from all the servers. Paste it. We are saying host all, then all, and from all the servers. Yes, yes. Okay, so now what we have to do is we have to add this line host all from all the server, and method must be trust so that it can authenticate it against the username and password. You have to use method trust, not MD5. So update that in pg_hba.conf. I have done it in pg_hba.conf. Now what we'll do is we'll stop and start the service. System ctl status Postgres SQL-14. Yes, it is running. What we'll do is we'll stop. Now we'll start. Say enter. Started. Check the status again. Yep, it is up and running. Okay, friends. So now what we'll do is we'll try to connect our DB viewer tool to this Postgres database running on EC2 instance. So I have opened my DB viewer tool. I don't have a connection. I am going to create a connection here now. But before that, I have to create a driver. Okay. So I'll be creating a driver of Postgres database. Yes. Yes. So now if we see Postgres SQL, I will say EC2. This driver configuration. The host name of our server is this. So I'll be giving that here in host name. Yes, and the port 5432, and database that will take is Postgres. Yeah, your Postgres 5432 Postgres. So this is the one, and library. So here we have to add a jar, add a file. That jar file project. The driver class we have to add Postgres driver class. Okay. This jar file we have added so that we can find this class. Find, say OK. It is saved and close it. Now click on the right side in database navigator, file, a new connection, and we'll select Postgres, the driver that we have created just now. Next. So here we have to give that host name again. We'll take that host name and paste it. Database name Postgres. We are connecting on 5432. User Postgres and password Postgres. And strike connection. Yes. So it is saying connected. Very good. Just say finish. So now if you see, we are now able to connect to that Postgres database running on a server. Let's see what is there inside that. So we have one default database, that is Postgres database. Inside that, let's see what all schema we have. It has public schema, that is default. What we'll do is now we'll create our own schema and we'll create our own tables. Okay friends, so now I'm connected to Postgres database and I'm creating this schema, customer microservice demo. Let's do that. And we are saying it is authorized by Postgres user. That means the Postgres user will be owner of that schema. Yes, it is created. Let's see. Let's refresh this. And if the schema is created, yeah. So this schema is created. Now what we'll do is we'll create a table here inside this. Okay. Let me do that. Okay, friends. So now I'll create a table inside this schema using this command. If you see create table, this is my schema name and this is a table name with 4 attributes: ID, name, role, and age, with primary key as a ID, right? Let me select this and create. Yeah. So the table is created. Let me refresh this. Yes. So now this is created and let's see what all columns we have. ID, name, and yeah. So now what we'll do is we'll try to insert some data in it and then we'll test it. Copy, paste. We'll say 1001, name Pavan, role employee, and let's say age is 30. Let me insert this data. Yes, it is inserted. Now let's fire select query and see if we are getting the data. Select star from. Yes. Yes, so we got the data. It is absolutely working fine. And let's fire a query dot customer where name is equals to Pavan. Let's see if this works. It is able to find by name. Yes, it is working fine. So we have successfully created a schema. We have created a table, we have inserted data, and now we have fired a query on it. So we have successfully set up the Postgres database on our EC2 instance. Okay friends. Okay friends, now let me show you my microservice project, what I have created. This microservice project will be connecting to Postgres database as a backend. So let me open pom.xml and show you my configuration here. So you can see here, I have dependencies for a Springboot starter and then a Springboot starter web, so that it is going to be a web application like my RESTful application, RESTful API, and then I have added a dependency for Postgres database so that I can work with Postgres database. It will download all the driver class and so on so that I can connect to Postgres database and interact with it. So these dependencies I have defined. Then in my project, I have this main class. This is my microservice demo application having a Springboot A application A notation. So this is my main class, and then I have defined controller, that is customer controller, and it has two endpoints in this controller. One is get mapping get endpoint, where we can get the detail of a customer by passing a name, and then we have another API to add a customer, where we'll be passing the customer details as a JSON, and that will go save into Postgres database. So these two endpoints are there. Then we have a business layer class, where we have defined two methods on the same way, to get customer by name and to add customer. And this service layer is going to interact with my repository layer. Let me show you what is there in my repository layer. So this is an interface that I have defined, is a customer interface extending CRUD repository. And here I have defined few methods like find by name. Okay, so I can search a customer by name and also by role, but find by ID is automatically defined and it will come from this CRUD repository. So I didn't need not to mention here. So find by ID, because ID is a primary key, as it will be supported automatically from this implemented interface. And then here we have a domain object. This is our customer domain object. It is an entity, and we have a table. It is mapped to a table customer, where schema name is this customer microservice demo, and it has four attributes like ID. Okay, ID, name, role, and age. And here ID is our primary key. We are saying that this is our primary key, and we are generating a value of this ID as a UUID. It's a string type of attribute, and in database it will be a text or a varchar kind of attribute, where we'll be saving the primary key as a UUID. UUID is 16-digit unique ID. So this is our classes that we have. Now I am going to build this application so that I can create a jar, and then we'll upload that jar to S3 bucket. Right, let me build this application for you. It's compiling the code now. It's saying compiling 6 files. Just give a minute. It's packing the jar. Yeah, it says build is successful. So now what we'll do is, now the jar is created, we will upload this jar to our S3 bucket. Now, so what we'll do is we'll create a S3 bucket so that we can upload our jar file to it. So search S3 service here, select S3, and then it will take you to the S3 management console. So here, if you see, there is an option to create a bucket, but I have already created a bucket. I will use that, but I'll show you how can you create a bucket. Click on the create bucket, give some name, my bucket demo. You can select a region where you want to. So we can say disable ACL, and then we will disable blocking of all public access. So we'll allow all public access to it, but you can select appropriate security option here, that which particular IP you want to give access, or you can give restricted access by selecting this point. Block public access accordingly. Then we don't want any versioning of this bucket, so disable it. And tag, if you want to create a tag, you can create tag. Encryption, select the default one. And what is there in advance? We don't want to change anything, just say create bucket, so it will create a bucket for you. The same way, I have created a bucket already and I'm using this bucket. So let me go to that bucket, but it doesn't have any object. So once you go, okay friends, so now what I'll do is I'll upload that jar to our S3 bucket. So let me go through S3. I'll go to S3 bucket, and as I shown you, I have already created a bucket. So this is my bucket. Let me upload a file. It doesn't have any file. Let me upload a file here. Add a file. Java target. Yes, this is my jar. Destination detail. This all okay. Permissions. We have to say grant public read access. Yeah, we understand the risk. So we are saying that allow it to be accessed publicly and say upload. It will take couple of minutes to upload the file. Yes, let's do that. Yeah, so it is uploaded successfully. Let me go and see. So here is the file, and using this URL we can download it, copy it into our EC2 instance. Now what I'll do is I'll go to my terminal where I've logged in into EC2 instance. We do wget command and provide that jar location. Yeah, so it has transferred that jar file. If I can see, yeah, so jar file is available. So now before starting our application, we have to install Java because Java is also not there. What we get from AWS EC2 instance is just an empty operating system. So all required software we have to install. So what we need to run this jar file is a Java. So I have a command, yum command, yum install Java 1.8.0. I'll use this and you can run it as a root or you can use sudo so that it will now download the Java and install it. Just say yes, it's downloading. It will take a couple of minutes to download and install Java. Yes, so it is done. You can say Java minus version. Yes, so it's showing up. Now what we'll do is we'll now run this jar file. We'll start our microservices. For that, we have to prepare a command so that we can select appropriate profile to run our application with. If you remember in the starting, I said we will running this with prod profile. In our application, we have two properties file, application.properties and application prod.properties. So here prod is nothing but it's a profile name. So I have prepared a command where I'm giving Java manager and this option where I can say what is my profile name. So spring.profiles.active is an option that I have to use, and I have to provide a name of my profile that is prod and the jar name. So copy this command and I'm pasting it here. Yeah, and then say enter. So it is starting my application now. Let's see if it starts. Yeah, so it says it started. Now what we'll do is we'll try to hit this API and see if we are getting a response. Okay friends, so now we'll test the get and post endpoints for our microservices. So here I have created an endpoint. Now I have to update this localhost with the EC2 instance host name. Let me do that. I have this instance. This is my EC2 instance name. Let me update this, and port is 8080. Okay, I'm running my API at this instance, and just to make sure that what all customer data I have, so I have just one record with the name Pawan. Let me try to fetch that. I am fetching it from this host name and port 8080 customers name Pawan. Let me fetch this detail for the customer Pawan. Yes, so I'm getting 200 response from that EC2 instance, and it's saying that ID is 1001, name Pawan, employee 30. Exactly same information what we see here. Now let me run another endpoint where we are doing post operation. We are adding a customer into our Postgres database. So here I am trying to add this new customer John into our database. Let me just change this host with my EC2 instance and port 8080. Let me hit this now. Yeah, so it says it's 200 successful and the user is added. Let's try to get that user John instead of Pawan here that we have added just now by name JOH and John. Yes, so we are getting that user here, and let us see again in the back end. Do we see now two users in the table? Yes, so we see those two users are available. First user is Pawan and second user is John, right? Do you see? Our demo end-to-end is working fine from creating the EC2 instance and then by creating the microservices, uploading to microservices, running microservices into the backend. So this is the microservices console which is running, and then installing the Postgres database, connecting the microservices to the Postgres database through a configuration file, and then testing it for the get and post contract. Right, friends? It's all working fine, absolutely fine. Now, friends, let me summarize what we learned in this video, right? So we created EC2 instance from the scratch, and then we connected the EC2 instance through our local putty, and then we created S3 bucket. Finally, I shown you how to create microservices, what all classes I have in the microservices like controller, service layer, and then repository layer with the domain object. Then we compile and build the microservice jar. We uploaded the jar to our S3 bucket so that I can copy that jar to EC2 instance. Once this is done, then we install and started the Postgres database into our EC2 instance. We did a configuration so that we can access it from outside, right? And then we deploy the jar, did a database configuration and started our microservices into EC2 instance, which is connecting to Postgres database as a backend. Then finally, we tested our microservices, getter and post contract successfully with the Postgres DB, right? So hope you like this video. If you like this video, so give it a thumbs up. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.